Hello, everyone, and welcome back to another episode of Subscriptions Scaled. Today, really excited to have Josh Murray and Scott Huff, who are both senior application developers and architects at Rebar Technology. And today, we're going to be talking about the benefits of serverless architecture. And so, guys, I guess to start off here really quickly, let's dive into the meat here. What is serverless?
Well, serverless is a mechanism that you can use to build and run applications without having to manage nearly as much infrastructure as you would usually have to do. This allows your team to have much smaller workloads when it comes to provisioning, scaling, maintenance. And overall, the main benefit is you pretty much only pay for what you use, as opposed to, having your server running 24 hours a day and continuously paying for that as time goes on. So.
Okay, so if I understand, this basically lets you kind of spin up and use the server as you need it, versus having a server sitting there that's reserved for you running all the time. Is kind of, from my understanding, you're running the server whenever you need to execute a command or you need something done. Is that accurate? Or?
Yeah, that's right. You basically will only use the server spins up as needed, and will stay spun up for a small amount of time just to speed up additional tasks that may come up. But you're not continuously paying for it. So definitely for small scale use, this is the ultimate thing, because if you have one user who signs in at 3:00 in the morning, and that's the only time that they ever use it, then you're only paying for that one request, as opposed to paying 24 hours a day for the entire month when they only used it that once. So it does end up making a lot of sense long term. So.
But one of the things with the serverless, as opposed to traditional servers or virtual servers in that sense, is that when you said a server spins up, you're still thinking in the old terminology and the old ways of doing things. With serverless, you're not actually, as a developer and as a team, you're not maintaining servers. Your platforms such as Google, Microsoft, AWS, and the other guys are actually building those servers for you, maintaining those servers. You're just running your code on those servers as a service. And so when that code spins up, you don't really care what server it's running on or what it's running in. It just spins up, runs your function for a few minutes, even a few seconds, and then shuts back down. And so as a developer or as a team, you don't have to worry about what that server is doing or even where it's at. And so that's where the serverless part comes in. I mean, like you alluded to, there is a server out there running, but whether that's a Unix server or a Windows server, you don't really care. It's completely agnostic to you. You just, your function runs, it does its job, or your code runs, does its job, serves that user in the middle of the night, and then shuts back down again.
Okay, perfect. And so what would be, some of the services or things that people can, I guess, kind of do or utilize with within the serverless ecosystem?
Okay, so there are a number of different, every cloud platform has serverless kind of services that they have out there. So if it's AWS or it's Google Cloud Platform or, Azure, all of them have their own version of things that live within the serverless ecosystem. For AWS, it's Lambda. Google's Cloud Functions. These are effectively the processing that takes place. So effectively, if you want to do a task, whether that be a big task or a small task, you can spin up a function. This function will run one time and perform a duty, whatever that duty might be. It's going to have some input, it's going to have some output, and it's going to it can be pretty good size or it can be small. We tend to try to keep, those small because they're just more efficient when they run. If you do keep them, compact. Those are kind of the heart and soul of all of serverless, but you have other things involved which can trigger those functions. So there's a lot of things just in the world of AWS, for instance. You can trigger a Lambda from an SNS topic, which is notification. So anything can send something to this notification service, and when a message is sent to that service, it can trigger one of these functions to fire. An API gateway. So somebody sends a web request. An internet website might send a request to say, "Hey, give me this piece of information," and that would trigger the Lambda to go collect the information and respond back with that information. It could be that you want this to, whenever I put a file in this folder, trigger this Lambda so that file can be processed. And that's just the starting point of all the different services that you can use to kick off one of these small functions firing. And a function can fire off and then automatically cause another function to fire, or it can send a message, or it can create a file, which triggers another Lambda. So it allows you to really track a request or the processing of information all the way through the system, one function at a time. All you have to maintain in all of that is really just the code. What do I want it to do when it gets here? That's the main thing. I tie it to this API gateway. So when a web request comes in, what do I want it to do? What do I want to give the user back? What do I want to write into the database? Whatever that might be. So beyond that, there are other implementations that are always out there that allow for storage solutions, which can be spun up, and only used, when required as well. So traditionally you had, a MySQL server, which is running your database, and it stores all of your data in there, but you have to, again, run that 24 hours a day. So there are data storage solutions now, which allow you to spin up, only write some information in there, and then spin right back down. So you're not continuously paying for that service to be up. And when you want to read from it, it'll spin up, provide you with the data you need, and then right back down again. So those things drastically can reduce costs. As always, with these functions, you can have logging, which happens, in real time. That information will be available in whichever, the cloud platforms you decide to use, Azure, AWS, Google. They all have logging that can tell you exactly what's going on inside your function, how much memory was used, those kind of things, so you can really hone it in to get it exactly where you need it to be, so it's using the very minimum amount of resources that it needs to in order to accomplish the task you've given it. So
kind of back to your original question, what can you do with serverless? You can do everything with serverless that you can do with a server, except in the middle of the night, your server's sitting there idling, costing you the same amount of money as it does when it runs in the middle of the day. Whereas with serverless, it's not costing you money in the middle of the night. It's just sitting there waiting. Someone else is using that resource and you're not paying for it. It's kind of like a shared service. And then with the serverless, you can stand up a website as a startup. You can stand up a website and have it up and running and be costing yourself $10 a month or less because you have so little usage. And then when your product gets big, as you got more volume, it scales up. The services start spinning up as more demand comes in. Those functions spin up, the database gets used more, and then your cost goes up with the usage. It's not some big investment up front where you've got these huge servers that are going to have to sit there idle until they get used. And so yeah, you can do anything you want to with serverless, the same as you can with servers. It's just, it's.
Yeah, a situation coming up where serverless can't accomplish the same goal that, a traditional architecture is very, very rare. I can say that, except for obscure type of web requests that exist out there, we have not found even one circumstance where a serverless can accomplish the same task. So.
Yeah. So with that in mind, then, why not make everything serverless? Why are companies not doing everything on serverless these days? What are some of the reasons that someone could still consider kind of that, more traditional architecture?
Well, right off the bat, you got to think about, you have your team. So if you have a development team and they're completely and totally used to working on servers that, they have set up and they are very accustomed to using just those traditional architectures, or if you have legacy systems, which maybe not even legacy systems which you're using right now, which are on those traditional architectures, taking something that was built in a conventional way and turning it into something serverless can be pretty daunting. The idea that you're taking it and cutting it all up into pieces and putting it into smaller sections of code, that can, especially with some of the services that have been run for years and years, it's a daunting task to think, oh, I have to take all of this and every little piece of it and put that now into a completely different architecture. So there's learning curves that are going to be involved in that. So to some level, you're going to need someone with some expertise on how serverless works. And then on the other side of that, you have to have somebody with expertise on how your system works and be able to really see if you can bridge the gap between where you are and what, and the benefits of serverless, see what the costs are going to be for you to develop, from your current architecture into a serverless architecture. And then, basically make the decision, is it going to be, cost effective in the long term for us to do that? There are other things too, if you want to, but in those circumstances, when someone is doing that, from our side of it, what we have done a lot of times is we'll say, hey, well, let's just take it one piece at a time. We can take this small section of your architecture, turn it into something serverless, and have it still communicate with your existing architecture. And then as time goes on, you can employ more and more serverless, and you just effectively, anytime you change something or add something new, you just continue adding that in a serverless way, and you can move into it slowly and not have to just drop everything and jump over to serverless all at once. And that's something that I feel like a lot of people aren't really as aware of as they might be in the event that, if they're familiar with the conventional architecture, switching everything over to serverless doesn't have to be all now. You don't have to do everything all at once. You can still work with, small pieces at a time. And beyond that, it's when you're running a server in at your location, if you have the physical hardware, in your office, it's difficult for people sometimes to think, okay, well, I don't want to run this in the cloud because of security. I need to be able to make sure that it stays on my network and people don't have access to it that shouldn't have access to it. And I don't want, this stuff to just be out in the world. Having said that, there are still some security concerns for people who are running their server in the cloud and have a provision there. There are the idea behind, hey, if I switch this and I'm not running this on a server anymore, how do I make sure that it's not accessible when it should be accessible? And there are answers to those questions, but they're not easy always to find. So again, it comes back down to, do you have somebody who has some expertise in serverless architecture, and can that person overcome the security concerns that you have? And we have built our application completely serverless, and we have complete PCI compliance, which is one of the most secure requirements that exists out there. And so I can tell you, we haven't come across still a security concern that we haven't been able to overcome, even within the serverless ecosystem. So.
one of the difficult things to think about when you're converting though is with a lot of things like when you're converting like from a server from one version to another version, you're keeping your concepts the same, you're keeping your thought process the same. But one of the things when you switch to serverless is when you're switching to that event level architecture, you've got to rethink how your application works a lot of times. The traditional way of processing your batches and processing your stuff just doesn't work anymore. You can't just what you consider a lift and shift. You can't just take what you've got and move it to the cloud or move it to serverless. You've got to rethink it. And what Josh was talking about earlier is, we take things as pieces, and kind of the best way to think of it is treat those pieces as like a third party. Like, hey, I'm going to take these and I'm going to integrate it with my existing system, but I'm going to integrate like a third party. And I'm going to say, hey, I'm going to send you this information and you're going to do it for me this way and send it back to me. The way you're going to implement it is you're going to implement it in the cloud as serverless. And then just, take my payment processing first, and then take my my billing, or then take my invoicing, or take my email communications. Take what your most painful thing is, your most expensive thing off of your existing system, move it to the cloud first. Get a feel for it first. One of the things we've had, seen clients do is they'll just move their servers to the cloud, and virtualize them, and then they're looking at a big beefy machine, and they'll provision that in the cloud, and not think about even when you're just talking about moving servers to the cloud, not just going serverless. You can still build smaller virtual servers in the cloud and have them build and scale up. And it's very expensive just to take a big machine and virtualize it in the cloud. And so even just moving stuff to the cloud and not going purely serverless can be expensive and make huge mistakes. And companies have done that. And so they've started down that path, made a few missteps. And because of that, $1 million invoice will cause you to rethink what you're doing, and they'll step back and, oh, we've tried that. We've been there. It didn't work kind of mentality. And so that's also a barrier to actually going serverless, that we've been there, we've messed it up. We're not going back there again.
Yeah. There are a lot of people that are very happy with how conventional architecture works because they've been using it for 15, 20 years. And so it's difficult sometimes to convince somebody that, a new way can give you just the amount of dramatic improvement. And really, as a developer, it gives you so much more freedom and capability than you ever had before, and so much less work to have to worry about.
Yeah. But they're experts in what they know, and and it's a learning curve. You've got to partner with somebody or bring on some people who are experts in the new style. Security is a major concern. You can't just go out there and start standing up serverless websites and not think about security and not have somebody on the team that understands it. Or you will see, you will have your data out there in free for everybody to come and get without realizing. So you do have to think about those things as you move to the cloud and to serverless.
Yeah. So what would be some of the other ways you guys would say that serverless compares to conventional architecture? Like, if people are thinking about this, what are some of the other factors or ways they should look at that?
Okay. Well, I'll say, I have worked in conventional architecture, doing servers, spinning servers up, all those things. There are some primarily it's a lot of work. You have to first, let's say you decided, hey, I want to run a server, however you want to do that, whether that's locally or it's in the cloud, it doesn't matter. First, you have to decide which operating system am I going to use? Are we going to do Windows Server or Linux, or what is it? And so if it's Linux, am I going to purchase one of the servers that's out there, or am I going to use one of the open source versions of a server that exists? Then you have to get the hardware, install the software on that hardware, or if it's a cloud server, you have to establish all that, provision it in the cloud so that it's set up to do it, install whatever software packages that you might need on that server, right? You'll have to, and at that point, once you have all the software up to date, everything's working, you've set up the network interfaces so that they can communicate with the internet in the proper way with your intranet. If you have like a local, network that you're trying to have certain communications go through, all those things have to be set up and provisioned on the server itself. At that point, you get to build and deploy code onto the servers, right? Whatever that might be. If it's a web server, you might be deploying, PHP code, or maybe Express app if it's Node.js, depending on what your actual services are doing. And then after you have deployed your code, you can start doing your testing and all those things. As time goes on, you're going to have to maintain those servers. You're going to have to make sure that the packages don't need updates. There's no vulnerabilities out there for those packages. You're going to have to ensure that you are looking out for network attacks and things like that that may come in and hit your server that you'll have to work around and avoid. When you want to scale, you're going to have to either increase the capacity of the server that you're using, or you're going to have to install load balancers and deploy more instances of that same server so that the load balancer can direct requests between them, all those things. That's how traditional server architecture works. And then with serverless, you can basically just take away everything except for build and deploy code.
You forgot. You don't have to if hurricane hits.
Oh yeah. Oh no. Then you have exactly. You have a emergency disaster recovery type of things that you have to deal with. Whereas again, with serverless, it's just build and deploy code. That's the major benefit. You can take away all of those extra maintenance and workload items, and you no longer need a Linux expert and all those things, on your team, because you're not trying to provision servers and things like that. Instead, you just need someone who can make the code do what you want it to do. So people who are familiar with whatever programming language it is you're trying to deploy, that's the difference. So that's some more things that you'll find when you're comparing it to traditional stuff. Beyond that, cost, configuration, how easy is it to scale, how easy is it to maintain, all of those things, grow, quite a bit when you switch from serverless to conventional, and shrink quite a bit when you go the other way. So, when you bring on a new developer to the team, right, and this developer, if you're using conventional architecture, you have to say, well, here's how our web server works, and here's the language we use, and this is where you put code, and if you want this to get updated, here's what you have to do, and so on and so forth. There's lots of steps, extra steps they have to take. They might have to connect to a VPN to get the code to deploy where they need it to go. There's lots of different things that can happen there. Whereas with serverless, you just give them permissions on whatever cloud platform you have, and they're off and running. So it's much simpler that way too. And again, reduces a lot of training and learning curve for new developers as well as existing developers too. So if you can get to a place where you're 100% serverless, it's going to save you money and time overall. So.
Yeah, and one of the other benefits we've actually come across that for developers is we can set up multiple environments a lot easier. When I was doing traditional development, they're like, "Why do you need 3 environments?" Like, we can do it with 2. We can just do it with development and production. We're like, what about testing? Oh, well, we can test in production, or we can test in development. I deployed an environment the other day that had 5. Just because I was like, I want 5. No big deal. 3 of those are sitting there idle, not costing us anything because they're serverless. No one said, oh, you can't have an extra 3 because you want them. No, I have them. They're there. There's no extra cost. And the nice thing is they're all configured the same. I don't have to. One of the things that we've had in traditionals is the development servers don't match the production servers. They were patched at different times. Try to find that error in production. Those are fun errors to track down. We don't have to worry about that in our environments where the servers are on different OSs or on different patch versions or different sub softwares are on different versions. We don't have to worry about that anymore. So yeah, just that hidden benefit of being able to have a QA, a testing, a dev, a demo, a production environment, a true production environment, or a production environment that points to dev that's 100% in production. We can have that just by adding another thing in our file that describes our environments. And it's a text file. It's nothing hard to understand. It's nothing complex.
So what are some of the other lesser known benefits of going serverless as well?
Well, although it's not really exactly serverless, when you use CI/CD, which is when you are running on a platform where you're constantly updating your code, and that's constantly updating your services, continuous integration, continuous deployment, CI/CD. When you're using that along with version control, so what we have is we implement pipelines which, as soon as we make changes to our code, that code can immediately be deployed directly into the cloud. So along with that code, we keep all of the resources that are required to run that code. So if there's a database, we have that provisioned, built into the code as part of the deployment. If there is an API endpoint, that's deployed with along with the code as well. And so when we do our deployments, everything that runs the service and is used by the service is deployed right along with the service. And so what that gives you is the ability to just update the code when you want to make changes to any resources or any of the configuration for your system. So if I update the code and I push that code up, into my version control platform, automatically it's going to be deployed for me to the cloud platform I'm using, and those services will be updated. There's also that it also gives you, in the case, depending on which cloud service you use, AWS gives you absolutely zero downtime. So when you deploy new changes to your code, if a request was going through at the moment you deployed it, that request will finish using the old code, and the next request will use the new code. So it's absolutely zero downtime whatsoever with that. So high availability is a great thing, that great benefit to it too. You basically are scaling automatically. Depending on, depending on which cloud platform you're using, they all have different levels of this, but, specifically AWS, they give you the ability to spin up and run up to 1,000 simultaneous Lambda functions that are all the same code. So if you have 1,000 web requests that are all coming in at the same time, and then you could effectively take 1,000 requests per however long it takes for that process to run. So if a user is saying, hey, give me a piece of data out of the database, and that happens 1,000 times, generally with our services, those are sub-seconds. So you're talking about, 100 milliseconds, 200 milliseconds in order to collect and return that data back to the user. So what that effectively means is if you're at 200 milliseconds, you could do 5 of those in a second. So 5,000 requests per second can be performed, with just what's given to you in a single region right out of the box with a Lambda function. So that's the kind of scalability that you can do. And 5,000 requests a second is extremely substantial. Not that you're going to use that right away. If it's a small startup, you're definitely not going to have that kind of capacity or need. But again, you don't have to pay for that kind of need or capacity. It's there and available to you. And it'll only be actually used when you need it and charge you when you need it. So that scaling that's built in automatically is a huge benefit that may not also be known right away. Backups. You want to talk about backups, Scott?
Yeah, one of the things with the databases out there is, when you're they have a point in time backups, automatically setting it to backup. Usually with databases, a lot of times you have to have a downtime to back them up, or you're talking about shipping tapes off to different third-party providers. You don't do that with the serverless stuff. You can set an event. You can time it. You can actually set up, serverless events that actually go out and back up your systems for you. They make it, you just set up a serverless event that says, hey, go back up my database. And it writes it off to a serverless storage system that will also archive it back. And it in itself is serverless. So, it's serverless serving serverless, and then your backups are available. We've got set up point in time recovery that's any point in the last 30 days. We've got backups that run, monthly. We set them up in like Josh was alluding to. We set it up in the configuration of the code, and then it's there if we need it. Not that we've needed it. Usually backups are for disaster recovery. With the redundancy of all these cloud providers, we've not had any down. What we usually tell our clients is if AWS goes down or Azure goes down, you got bigger issues than whether or not your website is up. You need to be more concerned about what's going on with your employees in their homes, because it's a pretty huge disaster, And you probably lost Netflix, so you probably want to check on your spouses, see what they're doing.
Beyond even that, you can there's architectural considerations that always come into effect, and over the last number of years, as Node.js has become more and more prominent everywhere, and real-time data traveling from one place to another has become more and more important. Event-driven architectures are have really taken the whole technology world by storm, and that's what everybody wants, is event-driven architecture. When some event happens, I want it to do this thing and this thing and this thing. If a new customer shows up, I want to send them an email, and I want to write a record of the database, and I want some other thing to be triggered and kicked off, whatever that might be. And what this serverless architecture gives you the ability to do is you can say, all right, when that event happens, send a message to this notification event bus, which in the case of AWS is SNS. You send an SNS message, and now you can have 1,000 Lambdas if you want to, different Lambdas which do different things, all subscribe to that topic. And when that topic is kicked off, it'll fire off 1,000 different tasks, which can do 1,000 different things. And if you decide, I don't want to send this email anymore, you can just turn that task off. And it gives you the really, really flexible ability to adapt the behavior of your application without having to rewrite the core of the code itself. So create a customer the same way you always have. But now, after that customer is created, the events that happen and the actions that are taken after the fact, those can change, dynamically on a whim to do whatever you want it to do. You can be more things, you can be less things. You can change the behavior of each of those things, but all of those things can be done without having to change what does it look like when we create a customer, So the website doesn't have to be rewritten every time. And you can set it up so the backend does 1,000 different things. And that has not traditionally been an easy task to accomplish. Normally you would have to change the entire code base, potentially recompile everything, push it all out there, hope that it works on the current version. When you're deploying it, you have to double check, make sure there's no, issues with the software you're running on your server, so on and so forth. But, Yeah. So lots of those things have been taken away, and this is almost perfect for event-driven, type of architectures. So we have, I've definitely enjoyed working with serverless a lot more than I ever did working on servers because it allows me a lot of freedom to just do the actual work that needs to be done and not so much worry about what type of server, how much memory I have, what kind of scalability I have to think about. So all those things are really a thing of the past that you don't have to worry about nearly as much. So.
Yeah, one of the things with like event driven, you could have as a new customer signs up, you could send them a welcome basket, right? And then later someone go, we're sending out a lot of welcome baskets and we're not getting any, we're not getting positive back from that. So let's move that down the event chain, and we don't send a welcome basket until we get, the customer. Let's wait a month, right? Let's wait 2 months before we send it, or let's wait until after the customer orders something. And so instead of that event that says, hey, send them notice to the fulfillment center to send a welcome basket, changes from being triggered from the customer creation to the first order being created. And then the event, it's still the same event. But now it's listening for a different, it's listening for a different trigger, and so you got, so the creating the account still does the same thing. Nothing changes there. The welcome basket, sending the welcome basket is still the same. It's just now what triggers it's changed. With event-driven architecture, that's easier to accomplish.
Yeah, you could even switch it to only send them if people sign up in December, whatever that might be. So that's the, definitely the benefits of it. And serverless just gives you all the tools you need to have your application driven in that way.
That's great. And so what would be some strategies for moving from, say, a traditional infrastructure to serverless? What are some of the risks people should consider as they go through that?
Well, you got to think about, when it comes to your existing architecture, how, first I always try to take into account anything that's going to impact a customer. So the things that are going to impact a customer, you want to be the most careful with, obviously. If the backend services is where I would tend to start when it comes to serverless, moving things that are front end services that are customer facing or that may have effects on customers are the things that I would move last. The things that you start with is generally the tasks which are in the back end and processing things after the fact, and they don't necessarily have a direct and instant effect on the customer. So that's something I would think about for sure. Moving, we talked a little bit about this. When it comes to switching everything over to serverless, probably the first thing that you want to do is talk to somebody who has some expertise in serverless. There's plenty of information out there that can be had about serverless, but the finding somebody who can understand, the needs of your business and what your business have, as opposed to just blanket kind of hello world type of applications there's a big difference between what you can find in a tutorial and what your company probably actually needs. So if you're building something from the ground up, going to serverless is easy. If you are taking something that already exists and you have a lot of integrated systems that are talking to each other and communicating back and forth, it can be really complex to make the change over to serverless. And long term, like I said, it can definitely be hugely beneficial as far as costs and how much workload there is. But it's definitely, I feel like most of the time it would be worth the undertaking, unless the development cost just doesn't make sense, And then I would always suggest to take it one small piece at a time. Anything new that you build, try to build that serverlessly and connect it to an existing system instead of just keep continuing to add to your conventional services. So if that makes sense.
Yeah, I mean, new projects are usually some of the best options for this but one of the things you've got to consider is your best experts are your existing developer teams, right? They know your business the best, right? So you're going to want to invest in them. You're going to want to send them, you got to remember they're applications developers, they're traditional server developers. That's how they think. There's a little bit of shift in I came from a purely application mindset. You got to think about things differently. I think about things, from step A, step 1, step 2, step 3, step 4. Now it's like, when you in an event driven, it's this event. This event happens. Now I want all these other events to happen. And they're not actually 1, 2, 3, 4. They're all step 1, A, B, C, D, all happen at once. You got to think about it slightly different. So you need to invest in your team, your current developers. If you go out and get all new experts in the serverless, they're not going to know your business. So you kind of need to have a mix. You have to have people that know your business, know what you're trying to accomplish, and then also bring on some experts and bring them together. You can't just get rid of all your existing developers. You got to transition them over. And new projects, I think they're usually the best for that. You're going to have a little bit of a investment in time and effort to get your development team up, but you're going to have your savings on the server side, not having to build those servers, not having those costs. If you're launching a new product, you got to think in a traditional world, you're going to have to build new servers to support that product. Instead of building those new servers, build out your team's knowledge on serverless instead.
It's great. And so as we wrap up here, if someone were to take away one key reason to consider serverless, each of you guys, what would be the one key reason that you think someone should consider serverless?
Well, I would definitely say flexibility. It gives you the ability to be flexible, to adapt to just about any need that's out there. Again, I said there are a number of different things that can trigger, one of these small microservice running. Those triggers and the number of triggers that exist out there allows you to just about implement anything in a very flexible kind of way. Even things that you wouldn't think are possible are definitely made possible, by using serverless. So flexibility, absolutely.
Scott, what about your side?
It's just a theme on flexibility. When you're looking at launching a new product and you're having to you want to be flexible in that. You want to be able to get that product out on the market. And when you go to your team, you're like, hey, I need to stand up something, and they tell you it's 8 months to order a new server because chips aren't available, and you can't. Your marketing wants to go next month. What do? You're not flexible anymore. I think Josh hit the nail on the head there.
You can spin things up really fast. I can spin up a new service tomorrow that will do everything you want it to do. And that's the benefit of it. It's so fast. You can put this stuff out there really quickly, make adjustments really quickly on the fly, zero downtime. Fast, flexible. Yeah. Absolutely.
I think we're kind of spoiled, Josh. Something the other day said it was going to take 30 minutes. And I was like, 30 minutes? I don't have 30 minutes to wait.
Yeah. Oh, no, I definitely
It didn't take 30 minutes, so I didn't have to wait that long. But yeah, 30 minutes.
I remember installing software on servers taking, 30 minutes to an hour, just to get the server spun up in the first place. So it's, that's definitely a distant past, concern for me. So nothing I have to worry about anymore. So.
Great. Well, thank you guys for taking the time. For everyone out there in the audience listening, if you are interested in learning more about serverless and you want to talk with these guys or any of the other brilliant experts at Rebar Technology, just head over to rebartechnology.com. So Scott and Josh, thank you for taking the time to share all of this with us today. You guys were great.